Hi, this is Todd Danielson, the editorial director of Informed Infrastructure magazine. And today I'm with Jack Dangermond, the president of Esri. Now, Esri at Autodesk must be a big deal, Jack. What brings you here? I heard there's a new partnership.
Oh, it's been fantastic. Several years ago, the Autodesk executives and myself got together and we thought we should really merge, connect our technologies. And this was largely driven by people who wanted to work at the data level across our respective technologies, GIS and BIM. Those are the primary main tools. And so we've been working at it at the engineering level, not just interconnecting our data, but also interconnecting our tools so that our respective tools can read each other's data. And this is in the process of transforming the whole AEC engineering, designing, building workflow, because it's providing, for the first time, direct data services from all the geographic data in the world into these workflows of building the next world or building the future. So that's sort of an abstract thing, but you asked me a practical question. How does it feel to be here? It's great. I mean, this is such a vibrant, it's almost as vibrant as my own conference. No, not quite, well, it's about the same. And you know, people are genuinely interested in this integration, bringing contextual geographic data into their work. And I think part of their interest is because it just saves a lot of money. A lot of what engineers and planners and designers and developers do is they get all this data. They spend a lot of money collecting new data, surveying new data, but if they could go to the web, the ArcGIS Online Cloud, and simply search for data and bring it in as a web service behind their design tools, BIM or whatever, man, it's a lot of time savings. So that's, I think, part of the enthusiasm is that.
Would you say that this evolving partnership is brought on by users trying to take advantage of the two different platforms?
Well, I think the partnership started originally with Carl Bass, and then now especially with Andrew. He's really got his eyes open, the idea of focusing on BIM as the integration platform and building partnerships both in his user community but also in technology companies like my own to connect things. And his mind is really to look at the bigger picture, his users. He's really focused on that. So he started it in serious talks with me a few years ago, and then working with our various teams has just gradually, brought the technology together and the data together.
So when you come to this event, are you here to make formal announcements of anything? Are you here to just talk to the leaders and the users, or what's the specific purpose?
Yeah, a lot of my customers are here. They're the large A&E firms, which is one of the largest growing segments of my business, actually. It's growing over 30% this year because engineering firms, small and big, are saying, I want to get some of that stuff and bring it into my engineering practice to look at things more holistically. So that's exciting to me. So yeah, I guess first to meet some of the heads of a lot of the big companies, also to meet with the Autodesk people to interconnect and make sure our technologies are working together. And then just for me personally, it's just a thrill to sort of reconnect with everything. It's a great event.
Great. So what are your main motivations or your feelings about how this kind of partnerships of GIS and AEC, what means the most to you as trying to build this and develop it?
Well, Esri's philosophy, and this is now our 50th year, by the way, is to build great software tools that help our users do their work better. And one of my great friends, Scott Morehouse, taught me that phrase. He's worked, with Esri for many years, and it really is a powerful vision that we have our eyes focused on what users need and want, and then build engineer really great tools, not just tools that work, but things that are transformational. So each year in our portfolio of tools, it is really to advance the methods and the technologies that enable our tools. So that's kind of my big focus, has been our big focus. The way Esri works is we're only about 60% the size of Autodesk, so they're bigger, they're public, but we do have about 350,000 customers, and they're all collecting this data and we keep spending their money. That's the way we think of it. We take about a third of our revenue and it goes back into R&D, and it keeps advancing the tools. So this integration part with the workflows in the AEC marketplace is just fascinating to me, because it really is making a lot of geographic data relevant, not just for science or not just for record keeping, not just for understanding, but for creating the future. And so all the engineers of the world, all the architects of the world are desperately trying to do their job better. Mm-hmm. And what this does, this integration, is not simply a technology thing, it's really a bigger contextual thing of evolving the planet in such a way that it considers all the things that we're screwing up now. Biodiversity, considers greater efficiency, so there's less climate change. It considers making cities more livable. And originally as a landscape architect, this gets me excited. Mm-hmm. The idea is that we're not only building tools for sector productivity, but also being able to integrate and look at the whole. And for me, that's what every engineer, every architect, every designer should aspire to do. Because at this particular moment in the history of the planet, the arrows are, in many ways, the arrows are going up. We're living in a more prosperous world. Where all of us are more prosperous, wealthier, less starvation, all those sorts of things. But at the same time, the natural world arrows are not so good. Biodiversity's dropping rapidly, and the climate change I need not speak. And so these contextual things, my big vision is that we can build a integrated solution or integrated solutions through empowering companies and engineers around the world to do their job better, to make those arrows go in the other direction, so that we have what I like to call sustainable prosperity. That's the great challenge for today's engineers.
So that the engineers and the users might better understand how this partnership might improve the tools, could you maybe cite some specific examples of work and how the two tools may help each other?
Well, yes, users are just showing me all the time. In New York, they're taking buildings built in BIMs and putting it on top of geographic data to evaluate the consequences on the environment, but also to bring in things like social factors into the designing of a building, and also the other built environment, other buildings around it, so they can visualize it, do view sheds, understand traffic impacts as a result of a building submission in context. Mm-hmm. In the UK, one of our customers is working with a bunch of firms there to design the next generation of railroad networks across the UK, and they've taken all the geographic data for all of the UK, terrain files, the 3D building GIS databases, the LiDAR data, the point clouds, the context capture information. They put it all together with BIMs, and you can fly around mm-hmm. the UK and see the whole planned next generation rail network and zoom right into the rooms in the subway stations. Mm-hmm. This excites me, because that may not just be about environmental, being more responsible environmentally or socially or whatever. It's also the idea that for the first time I can see the whole thing as an integrated system. And moreover, I can see that not through some fancy, expensive workstation. No, I can see it on the web through a browser. So that means I can publish what we call a 3D scene. That's a 3D model at scale with millions of features in it, and I can put it out on the web, and millions of people can view and interact with that and touch it. So this is the power of GIS. So that's one of my big objectives. And then I'm finding there's lots of powerful GIS tools that engineers can use to change and alter and do things better in their own practice. Things like we have applications for field data collection, Survey 123, or we call it Collector. These are being used by millions of people in science, and for example, the 2020 census in the United States is using our Collector technology, or parts of it, to collect the census. Same in the Philippines. So this field technology can be integrated right into the engineering workflow to collect data in the field on a project, automatically put it onto maps, then integrate the maps into the overall workflows of a project. And that's true in mining, it's true in field construction activities. So there's these interesting connections that while our GIS tools weren't designed for exactly that purpose, by bringing these two technologies together, all of a sudden there's this little synergistic explosion occurring. And that's what I think the reason why this show is so very interesting in talking with customers.
Okay, so if I have a design firm and I make a building model, right?
Yep.
And I'd love to incorporate, the surrounding terrain, the other utilities that are around. How do I go ahead and get that data? How can I access it and then use that into the model I've created? Well,
it required engineering, software engineering. So what Autodesk has done is engineered their product lines like Revit, like AutoCAD, like InfraWorks, so that their tools can actually read our native data services as if it's a native data that was designed and built by the Autodesk tools. So they buy a $500 subscription a year to something called ArcGIS Online. It's the Esri geospatial cloud environment. This geospatial cloud has about 8 million users, and it adds maybe 7,000 new users every day. And those users share their information. Not all of it. Some of it they keep private in the cloud, but they can share it publicly. So right now there's over 28 million data sets of maps and imagery that have been shared. And you can also share, by the way, files in their Revit files, CAD files, and people can search the ArcGIS Online environment and they discover within a geographic context and thematically, semantically, layers of data, or more often than not, web services, web maps, that they can just bring right into their design practice. So I'm going to do some building here. Why don't I just bring in the soil map, the vegetation map, the slope map, the flood map, overlay those kind of like plastic overlays, except do it in an analytic environment, and then design around it so that I minimize environmental impact or avoid hazards, or take advantage of a site. And that's particularly relevant for larger landscapes. But look at a city. I'm building a brand new building. I want to bring in the 3D GIS-based model of New York City, and I want to test alternative building configurations in the city and kind of understand their view shed. So I'm doing that either within the Autodesk tools themselves, or they can do it within Esri tools as well.
So they can access a lot of other information without having to fly their own drones or soil their own samples, access the tools that are already out there, and to make better models for themselves.
And they can also use that cloud to store their data. So if they fly a drone environment, they can upload their imagery into my cloud environments from their drone, and it's managed there. And then they can read it into their design tools. So it's an integrated environment for virtually any kind of imagery, any kind of CAD data, the Revit files, the IoT. So many of our users have living maps. They bring in IoT, like where the traffic is, or what the temperature registers are in a city, or what the pollution levels are. And those are real-time services that they register inside of my cloud. So it's not just using other people's data, but it's also storing and managing your own data for reuse. So oftentimes people will use our desktop tools, ArcGIS Pro, and they'll build a beautiful map, and they'll build a beautiful 3D visualization, and they right-click it, and they send it over into our cloud, and it automatically turns it into a service that you can look at in a browser or on your device using web services, and beautiful graphics in multiple ways. So would you imagine that your data that you would create, expensive data to collect or author or models, could be right-clicked and sent over to a server and beamed out for free access by anybody in a browser for $500 a year? No, I mean, it's like a miracle. So that product line for us is really growing very rapidly. We have desktop tools, ArcGIS Pro, we have server technology, and then we have this cloud environment that is like, we make over 1 billion maps a day in that cloud environment. And it just keeps growing. So basically that platform, we say, just among ourselves for joking purposes, we say, that platform is making the maps that run the world. I mean, that is not, I mean, our users are making the maps that run the world, but the platform is serving the platform.
So speaking of platform, I'm guessing it's probably also popular for public presentations, for clients, or public meetings.
Yes.
Simple and cheap, right?
Simple and cheap. And some of the firms here that I've been talking with, they are taking their projects and they build 3D scenes, and then they put them out through a browser to their customer, so the customer can look at the status of their project, whether it's first, architectural version, second, third generation of urban design, for example. They can mark it up, they can sketch even though they're 5,000 miles away. There's this idea of global collaboration by using cloud integration of the data mashed up with other kind of data. So yeah, it's a very empowering capability.
Nice. So one of the first references to smart cities that I ever heard was through Esri and some of the work you were doing, a long time ago. I noticed at this event there is something called ArcGIS AEC collections. Can you tell me a tiny bit about what that is and then how they can be used to help develop smart cities?
Well, there's lots of definitions to smart. IBM started about 10 years ago with the idea of a smarter world, smarter planet, and that was really a great marketing coup. And everybody expected IBM to come in and have smarter cities, smarter utilities, and so on. That didn't actually get realized, but the term that they had and the vision that they had was really correct, that you could do analytics, you could do real-time IoT integration, you could use visualization tools like GIS to be able to make a city smarter. So today, the term IoT, the term smart is used in the real-time environment quite a bit. The idea of real-time digital twins, or it's also being used in the data science world. Like we can do the analytics that would really help us understand. So that's another definition of smart, so it's real-time and analytics and connected. My own interpretation is all of that and geographically integrated, meaning all the data from different parts of the departments are all able to be served together into a dynamically integrated, real-time digital twin. So you have a living city, and that all action and all activities are interrelatable using location as a common key for bringing it all together. And that we have been working on as kind of an aspirational goal for our customers, to help them make their cities, those who are urban customers, smarter through this idea of real-time integrated smarter analytics. With respect to the Autodesk collection and the AEC collection, it's really bringing that environment alive and empowering. This is the very same tools that I've been talking about, both on the Autodesk side and on the Esri side. And we ourselves are making offers available to customers that want to do this, or packaging of the different combinations of technology that helps them with training of the technologies most of them already own, as well as just a vision for how they could wire these things together.
Right, with cities, when they've got multiple utilities, transportation networks, they're all separate, but they're all brought together by the location that they have in the city.
You said it.
At that point, isn't it just a matter of finding ways to share the information properly, only giving access to those who should need it, and then how are some of those things behind the scenes done?
Well, when I look at the last 50 years, that vision we talked about in the late 60s, the idea of bringing everything in the city's information together. And at that time, the way to do that integration was you bought a big mainframe computer, and you had little guys with white coats, and to get in there, you could access the data, and programmers could only do it. In the late 80s, late 70s, that started to evolve into mini computers in the different departments, and they would all automate their work, and then people would get mad because the data wasn't really integrated across the different agencies. So you'd have exchange files and exchange standards for exchanging data. In the 90s, companies like Oracle and Microsoft and others had this idea, okay, well, just put all your data in one big data bank, one big DBMS technology. So in the 70s, it was mainframe computers. In the 80s, it was kind of a distributed mini computer. And in the 90s, it was put it into a central data bank. The trouble is, not everybody wanted to share their data. So what's happened in this next generation, which is now really being realized, is that instead of centralizing the data, we can distribute the data, but view it across the web as web services with open APIs, REST APIs, that allow us to integrate the data as if it's in one data bank dynamically. That means all the separate departments can keep maintaining their individual data sets. The water agency does theirs, the electrical agency company does theirs, planning does theirs, cadastral, tax parcels, all of them, all the different roughly 100 or so activities that happen in a city can independently manage their own data, but using strong networks, they can integrate the data dynamically as services. So you have this vision of an integrated city that you can bring all together now. And that's what GIS really provides, using location as a way to interconnect all those distributed sets. So while people like to say, oh, Esri is just a GIS company, actually GIS is transformational in the sense that it can bring everything together using a common key called location. And the world is waking up to that. Places like Abu Dhabi, places like Raleigh, North Carolina, thousands of my customers are suddenly starting to bring their organization together using the interconnections and power of location to do the dynamic bringing together. And in the AEC world, that is really exciting because they are people that are building transactions on the virtual, digital twin of cities, of counties, of states, of the built environment. And those transactions on that distributed services thing can be brought together to see the whole. And that excites me a lot, as you can see.
Why do you think people are now finally waking up, as you phrase it? What happened?
I think that it isn't people just waking up because we talked about those things in the past. I mean, there was always visions of the spatial data infrastructure back in the 80s and the 90s and so on, but the technology wasn't there. I mean, the centralized computer wasn't it, because it was too expensive and inaccessible. The centralized database, not everybody wanted to give up their data, and you couldn't have a database big enough to support everybody's kind of transactions in the living city, particularly with the IoT. But today, what we're seeing is with distributed computing, things like faster independent machines, interconnected by high performance networks, what we're seeing is the emergence of a kind of nervous system that can interconnect the different databases in a city. So part of it is the technology, frankly, and also computing is faster, so we can do distributed computing. Why are Kubernetes and microservices now showing up as the new big rage? How can we actually separate these machines into little teeny machines that have them all interoperating? That's because the technology is evolving. So the way I see the world going is that it's all going to be interconnected. Everything that moves will be measured. Everything that changes will be measured. And it's already almost there. And it'll be interconnected. So what? It's interconnected. That was the web. That was Tim's vision. Okay, we interconnect everything. But how do you actually integrate everything? So it's not just interconnected, it's integration. And that's the power of geography, the science of our world, to bring all the pieces together. And then the power of mapping, the geography integrates it, and analytics, spatial analytics, spatial AI, whatever you want to call it, can do the analytics and prediction. And then visualization is there through 3D visualization and mapping. So all of these pieces are now, to answer your question, technology is enabling us to do it. And that's causing, right now, in many organizations, transformation. I mean, people like to talk about transformation. Everybody says, we're going to have a digital transformation. Well, geography, here's the tool, the science, a very intuitive tool. We all know it, we live with it. And GIS is the technology that is creating or enabling that, and of course behind that is what some people would call location.
Okay, so we've talked a lot about the software, tools, technology. I want to talk about the people behind it all.
Yes.
How can the different groups, let's say the the AEC people, the GIS experts, what can they learn from each other so that they can create better models, do better work, and have better projects?
Well, they are getting interconnected by the web, but that's not enough. Interconnecting services with common registries like ArcGIS Online or what we call ArcGIS Portal are showing up in different organizations, and that's interconnecting people. But I have a lot of belief in face-to-face meetings and interaction with people, because that's really where trust starts, and collaboration really operates at the speed of trust, somebody once said. So I think humanness, willing to share, willing to collaborate on the great challenges that we're facing as a global society is essential. But then there's another factor, which is leadership. And yesterday I was speaking to the U.S. Army Corps of Engineers, and they have great top-down leadership there. The general that runs it really gets GIS, and he's really organizing and transforming his organization along those lines. But leadership at the top is not enough. I think of leadership up and down. You need technical leadership. You need volunteerism, the willingness to participate, the willingness and desire and the values to be able to collaborate and work together. And you say, well, how the hell is that going to happen? Everybody's kind of selfish and they look after themselves and so on. Look, the great challenges that you and I are facing demand it. I mean, it's going to take every bit of our best science and our best engineering. It's going to take all of our best creative design thinking, and it's also going to create this idea of humanness collaborating if we're going to turn this around.
Okay, so I guess what I'm wondering is, let's say you've got an amazing building model designer, you've got a GIS expert, you put them in the same room, what can their different perspectives and expertise teach each other?
Well, the building designer can learn to use geographic information. I like to call it geodesigning, bringing in geographic information to help them design. It's another factor in their overall design. It's another parameter that they need to bring in. So it's learning the concept of geodesign, which means when I do alternative designs, I'm being guided by geographic context that's saying it's more suitable over there than here. Now, the reality is my users are doing it all the time. Starbucks, they locate their stores based on lots of layers of data. And so does Walmart, and so does Walgreens, and so does Harley Davidson. In the private sector, they're all using geography to help them pick the right location. But then how do you factor a particular building? How do you design a particular building within, design, Ian McHarg would call it design with nature. So bringing those geographic factors, both environmental factors but also social factors, into a design frame, that's what engineers and architects need to learn. My background was landscape architecture originally, so we grew up with that idea that we look at the landscape as a way to design a future. So that I just believe that by having accessible that information, people will understand and learn to understand as a discipline. And I would just say to all of you listening, this is something I wish that you would aspire to do, is to design in context, not just design to be, something artsy craftsy or to show a especially interesting building. Not that that's wrong. It's just that if we're going to have a future, we've got to learn how to go with the grain of what nature is telling us and grow with the grain of what cities are able to quantitatively now tell us with all this great data. So that's geodesign.